Hello, mechanical engineering friends. How are you? Welcome to another mechanical engineering board exam license reviewer. Today's topic is on power plant design regarding the HVAC minimum discharge capacity for a pressure vessel containing ammonia. The problem says, oh, and please remember, if you have a problem, we have a solution. So the problem says a 29.53 inch by 39.37 inch pressure vessel contains ammonia with F 0.041. Compute the minimum required discharge capacity of the relief device in kilogram per hour. Okay, analyzing the given, we've got a pressure vessel containing ammonia with F equals 0.041. The diameter of the pressure vessel is 29.53 inch and the length of the pressure vessel 39.37 inch. The unknown is the minimum required discharge capacity of the relief device in kilogram per hour. Okay, before we go to the solution, I'd like to invite you to please subscribe, like, and share. Okay, share the knowledge. Please and thank you, and we're back to the solution. So from the ASHRAE Standard 15 Safety Code for Mechanical Refrigeration, we have the following formula here. C is equal to F times D times L, where C is equal to the minimum required discharge capacity of the pressure relief device or fusible plug for each pressure vessel in kilograms per second. And F is the factor dependent on the kind of refrigerant from the discharge capacity chart. D is the outside diameter of the pressure vessel in meters. L is the length of the pressure vessel in meters. So for this, we are given the dimensions of the pressure vessel in inches. So we need to convert this inches into meters. Okay, so we convert D into meters. We just divide by 39.37 because 39.37 inches is equal to 1 meter. So we got D as 0.75 meters. We do the same for L. We divide by 39.37. We got 1 meter as our length. Okay. Now we are given F as the factor right there, 0.041 for ammonia. next step would be to substitute the given values and calculated values into the formula. Okay, we got the working formula. C is equal to F times D times L. C is equal to 0.041 times 0.75 times 1. C is equal to 0.030 kilogram. Sorry, C is equal to 0.03075 kilogram per second. However, the problem requires that we need to convert the kilogram per second flow to kilogram per hour flow or capacity. So we just multiply by 3600 in order to get the kilogram per hour of capacity. So now we get C is equal to 0.03075 times 3600, because 3600 seconds is equal to 1 hour. So now we got C is equal to 110.7 kilograms per hour. And that is our final answer. Okay, dokes. I hope this was helpful to you. If you have any comments, please leave them in the comments section. And please remember to subscribe, like, and share. Okay, cheers and have a good one.